The AI revolution has an energy problem, and it is bigger than most people realize. Every time you use an AI model, ask a question, generate an image, run a search somewhere in the world, a data center consumes electricity to respond. Not much for a single query, but multiply that by billions of interactions every day, and the numbers become staggering. This is AxisShift. In previous videos, we covered the machines that make AI chips, the island that manufactures them, and the cloud infrastructure that runs them. Today, we reach the layer underneath all of it: power. Because without electricity, everything we have covered stops. The chips go dark. The data centers go silent. The AI models go offline. And right now, the world is struggling to supply enough of it. Global data centers already consume more electricity than many industrialized nations. And AI is accelerating that demand at extraordinary speed. The International Energy Agency now projects that global data center electricity consumption will exceed 1,000 terawatt-hours by the end of 2026. That is the equivalent of Japan's entire annual electricity usage, consumed not by a country of 125 million people, but by the infrastructure running artificial intelligence. AI-focused data centers grew their electricity consumption by 50% in 2025 alone. And the computing power needed to train frontier AI models is exploding. Every new model is more powerful than the last. Every new model requires more energy than the last. Here is what that looks like in practice. A conventional data center rack consumes between 10 and 14 kilowatts of power. An AI data center rack, packed with the GPU clusters needed to train and run large models, consumes over 100 kilowatts, 7 times more power per rack. And the hyperscalers are building thousands of them. The capital expenditure of just 5 technology companies exceeded $400 billion in 2025. And spending is accelerating even further in 2026. To put that in perspective, the capital investment of 5 technology companies is now larger than global investment in oil and natural gas production combined. The energy industry that powered the 20th century is being eclipsed in investment by the AI infrastructure powering the 21st. But here is the problem. The power grids that supply this infrastructure were not built for it. Most of the electrical grids operating today were designed and constructed decades ago. They were engineered for a different era, a one-way flow of power from large, centralized plants to distributed customers. They were not designed for the concentrated, enormous, rapidly growing power demands of AI data center clusters. The grids powering modern civilization are being pushed into territory they were never designed for. And the consequences of that mismatch are already appearing. 7 of 13 major United States grid regions are projected to operate below their critical safety margins by 2030. In plain terms, blackout risk is rising, not as a distant theoretical possibility, as a projected operational reality. The infrastructure behind modern life is beginning to strain under the weight of artificial intelligence. In Virginia, the data center capital of the world, utility companies are struggling to keep pace with connection requests. In parts of Europe, new data center projects are being delayed or rejected because grid capacity simply does not exist to support them. Access to the grid, not chips, not capital, not algorithms, is increasingly becoming the binding constraint on AI development. Which means the AI energy crisis is not just an environmental concern. It is a strategic one, because the companies and countries that can secure reliable, affordable power for AI infrastructure will have a fundamental advantage in the AI race, and those that cannot will fall behind. This creates a new kind of geopolitical competition, not over oil fields, over power grids, over renewable energy capacity. Microsoft, Google, Amazon, and others are now racing to secure dedicated power sources, signing long-term agreements with nuclear operators, investing in small modular reactors, and acquiring stakes in renewable energy projects. Microsoft signed a deal to restart a reactor at 3 Mile Island, the site of America's most infamous nuclear accident, specifically to power its AI data centers. Google has contracted for geothermal power in Nevada. Amazon has acquired nuclear-powered data center sites. The same companies promising a green future are now racing to secure any reliable power source they can find, because the alternative, not having enough power, is for them unacceptable. And the environmental calculus is complicated. Data center emissions are projected to double by 2035. The same organizations making bold net zero pledges are simultaneously signing long-term energy contracts to guarantee supply. There is a deeper layer to this story. AI itself may help solve the problem it created. AI is already being deployed to optimize power grids, predicting demand, reducing waste, extending the life of aging infrastructure. It monitors transformers and grid equipment to prevent unexpected failures. It helps integrate renewable energy sources more efficiently into existing grids. The technology consuming so much electricity may ultimately become one of the most powerful tools for managing the global energy transition. But that future is years away, and the crisis is happening now. So what does this mean for you? If you own technology ETFs, the energy cost of AI is becoming a material factor in the financial performance of the companies inside those funds. Electricity costs are projected to represent a growing share of AI service costs through 2026 and beyond. Companies with secured power hold a growing competitive advantage over those still competing for grid access. Power is becoming a strategic asset in the AI era. Not metaphorically, literally. We covered who controls the machines that make chips. We covered who controls the chips themselves. We covered who controls the cloud infrastructure that runs AI. Now we have reached the foundation of all of it. Because underneath every AI model, every data center, every server running the intelligence of the modern world, there is a wire. And on the other end of that wire is a question the entire world is trying to answer. Because the future of AI may ultimately depend on something far older than software: electricity. Where does the power come from? Subscribe to AxisShift, because the world is turning and you should know which way.